My name is Javier Weeks, and I am currently a second-year mechanical engineering student at the University of the West Indies. This video presentation discusses the final year project proposal of improving hovercraft maneuverability. A hovercraft is an amphibious, air-cushioned vehicle that floats over the surface it is traveling on, with little to no physical contact. Hovercrafts are relatively frictionless compared to more conventional vehicles. Hovercrafts work by creating a cushion of pressurized air between itself and the surface it's on, using a flexible skirt that runs around the edge of the craft. An engine powers a fan that blows air underneath the hovercraft where it is trapped by the skirt. Increasing the fan power raises the volume and the pressure of the air cushion until the entire craft is lifted off the ground. When the craft reaches its maximum height, air begins to escape from underneath the edge of the skirt, and the craft literally floats on air. Once the craft has begun to hover, it requires little additional energy to propel it forwards. Propulsion can be achieved by diverting some of the air from the lift fan or by dedicating a separate fan to creating thrust. Steering is usually achieved by mounting rudders in front of the fan, producing thrust. Hovercrafts can comfortably travel over land, water, ice, snow, mud, marshlands, sand, gravel, grass, and deserts. Hovercrafts can also hover over swift rapids and floodwaters, since they are not affected by underwater currents. Some hovercrafts can even be modified for flight by attaching removable wings. As a result of the lack of friction, hovercrafts are very fuel efficient compared to more conventional vehicles. They are typically 100% more fuel efficient than boats of similar size and capacity. Hovercrafts can cruise comfortably at 20 to 30 miles per hour and also reach impressive speeds of around 84 miles per hour. They require less horsepower to achieve the same speeds as comparable boats. Hovercrafts do not need special facilities or equipment such as docks or anchors, since they can simply drive onto land. Additionally, hovercrafts do not have to worry about collisions with submerged objects and are relatively safe around swimmers. Hovercrafts have the potential to become popular mainstream vehicles. However, before this can happen, several challenges need to be addressed. The objective of this project would be to investigate and provide solutions for some of the problems that prevent hovercrafts from becoming mainstream vehicles. The project will focus on improving hovercraft maneuverability. Poor maneuverability is one of the most fundamental challenges to hovercrafts today. The lack of friction means that hovercrafts have overcomplicated steering techniques and no effective braking method. To make a simple turn, a pilot has to first rotate the craft and then apply thrust in the desired direction. While the turn is being performed, the hovercraft will continue to slide in the direction of initial travel. In order to stop, the pilot either has to reduce lift power so that the skirt drags on the surface, or turn 180 degrees around and apply thrust. Neither of these methods is very effective, and the first may actually cause damage to the skirt. Hovercrafts also have the tendency to slide down slopes and can be blown off course by strong winds. Additional challenges that could be investigated include improving the durability of the skirt and reducing the noise generated by the craft. If practical and feasible solutions to these problems can be found, the challenge of making hovercrafts mainstream would be diminished. Another principal objective of this project is to design, build, and test a prototype with solutions incorporated into its design. Due to the time and resource constraints, the prototype will likely be built to scale. However, once it's able to show proof of concept, it would be satisfactory. Hovercraft technology is full of promise and has many potential applications, some of which include search and rescue, military, and Coast Guard vehicles. Other uses which are more relevant to Caribbean countries that rely on tourism include sporting and recreation, and ecotourism vehicles for exploring natural spaces. One of the bolder applications of hovercrafts is its use as a water taxi or ferry. Water taxis could provide significant savings in fuel and time because they can take a much more direct route and avoid traffic on land. Hovercrafts would be able to pick up and drop off passengers at spots in between the points of departure and destination. Ideally, a hovercraft taxi would be able to land on a beach, drive up to the nearest road and drop off a passenger before returning to the open water. In addition to enhancing local transportation services, hovercrafts could also provide regional transport between the different territories of the Caribbean. This would be a welcome improvement as the region moves towards Caribbean integration. In conclusion, hovercraft technology represents an underexplored area of knowledge that holds the potential to provide unique transportation solutions, not only for the Caribbean, but also for the wider world.